The topic of this video is multiplying single-term radical expressions. Let's look at 5 problems. Alright, for all 5 of these problems, the instructions say multiply. We've got the square root of 10 times the square root of 10 for our first problem, the square root of 6 times the square root of 8 for the next one, the square root of 3 times the square root of 27 for the third, the square root of 14 times the square root of 2 for the fourth, and the square root of 3 in parentheses squared for the fifth. Okay, let's begin. Let's start with the first one, square root of 10 times the square root of 10. So we remember from our previous video that the square root of a non-negative number times the square root of the same non-negative number is just going to give us that non-negative number as our answer. So the square root of 10 times the square root of 10 is 10. There are a couple of ways to get there, and I'm going to show you those ways, but it's my hope that you're simply going to remember this shortcut. So 10 is non-negative, so that means we can combine these two radicals into one. 10 times 10. Since this is a square root, we're looking to make pairs. Well, we have a pair of 10s. Each pair sends one representative out to multiply. And if all factors group up, leaving no factors underneath the radical symbol is removed. That is how we get the answer 10. Okay, next problem. 6 is non-negative, 8 is non-negative, so we can combine the two radicals into one like this, 6 times 8. But we're not going to write 48. Instead, we're going to break these down smaller. 6 is 2 times 3, 8 is 2 times 4, and that 4 itself can be rewritten. Notice that I'm going to keep everything else the same. I'm just going to change the 4. 4 is 2 times 2. If I want, I can rearrange these so that all the 2's are together. And now, since this is a square root, I'll make my pairs. So, here's a pair, here's a pair. Each pair sends one representative out to multiply. So I get a 2 on the outside, another 2 on the outside, and a 3 that remains inside. Multiply the outside stuff, multiply the inside stuff, we get our final answer, 4 times the square root of 3. Okay, next problem. 3 is non-negative, 27 is non-negative, so these can be combined into a single radical. Do not multiply to get 81, instead make the thing smaller. Okay, so the 3 I've already written, 27 I will write as 3 times 9. And 9 can be broken down further, so the 3 times 3 is already written. The 9 becomes another 3 times 3. This is a square root, so I'm looking to make perfect pairs. So there's a pair and there's a pair. So each pair sends a 3 outside to multiply, leaving nothing under the radical. And 3 times 3 is 9. Final answer, 9. All right, square root of 14 times the square root of 2. 14 is non-negative, 2 is non-negative, so these can be combined into a single radical. Now, 14 is 7 times 2. And then, of course, I have this extra 2 here, which follows it. I'm looking to make pairs. Here's my pair. So, a single 2 on the outside and a single 7 on the inside. Final answer, 2 times the square root of 7. And finally, an exponent tells me how many times to multiply a base by itself. So this is really saying, what's the square root of 3 times the square root of 3? Notice these numbers match, so I'm expecting the answer 3. That's the shortcut. But if you don't remember the shortcut, 3 is non-negative, 3 is non-negative, so these can be put together. I'm looking to make pairs. Here's my pair. So a single 3 comes to the outside, and because I had perfect pairs with nothing left over, nothing underneath the radical, and that's where my final answer of 3 comes from.